Good day and welcome, class. So this time we are going to discuss deflection of beams using the area moment method. Deflection of beams is actually one of the highlight of your subject, mechanics of deformable bodies. So remember na yung beam is isa yan sa structural member. And normally, beams are investigated by its deflection, lalo na pag mahaba. Okay? We cannot really prevent members to deform, or to deflect. So, meron at merong deflection yan. So, why do we need to compute it? For us to have a design criteria so that we will come up with a tolerable deformation. So, in short, hindi man natin mape-prevent, but we can really control the deformation by an appropriate design. So, by that, we should establish our skills in determining the deflection of beams at any point. So for our learning objectives, at the end of this module, you will be able to relate with the theorems of area moment method, and we will learn how to apply the theorems of the area moment method, and then compute the deflection of beams at any point within its length. So today, you are going to appreciate the learnings you have from your recent lessons on the moment diagram by parts. So before we will go into the theorem, let us have these key concepts to remember. So first, the deformation of the beam, which is changing, is represented by the line called elastic curve. So we usually illustrate the elastic curve. Sa mga previous topic natin, elastic curve is essential in establishing equations. And then next, rotation is allowed for pin and roller supports. Hence, the elastic curve has a corresponding angle with respect to the horizontal line. So, kapag meron tayong pin at roller, allowed yung rotation dyan. So, magro-rotate at magro-rotate yan sa roller support at sa pin connection. So, there will be a corresponding slope of the elastic curve. So, yung mga points dito, may angle yan. At yung point dito sa roller na to, meron ding rotation yan. Kasi kaya nga, it is allowed when we have a pin and roller support. But not in a fixed connection because rotation is restricted at fixed support. Kaya nga, meron niyang internal reaction na moment. Okay? Kaya hindi niya pinaparotate or it is restrained at the fixed end. Okay? At the fixed support. That is why, pag gumawa tayo ng tangent line, considering our elastic curve, dito sa bandang fixed support, horizontal yan. Meaning, the rotation here is equal to 0. So, we have 0 rotation. So, horizontal yung tangent line mo dun sa elastic curve on the fixed connection. So, similarly, horizontal rin yung tangent line dun sa maximum deformation. Remember, kapag maximum, nandun yung peak or the peak of the curve is located at the maximum deformation. Except for yun nga sa fixed support or sa prop beam or sa overhang na beam. So, normally, andun yung peak kaya yung slope niya, horizontal line. Okay? Same true kapag free-falling bodies. Pag initya mo yung bola, that is against the acceleration. And then, there will come a time at that peak point, mag-iiba, transition. There will be a transition at the peak point and then it will go down. So, meaning ito, yung transition is the slope on the transition is equal to 0. Okay? So, another concept to remember is that deviation is the vertical distance between the elastic curve and the tangent line drawn from any point of the elastic curve. So, ito yung elastic curve, ano? So, if we are going to make a tangent line at A, there will be a corresponding slope at A kasi nga yung A is a pin connection. Okay? A pin connection. So, ngayon, meron na tayong elastic curve at tangent line. So, if we are concerned with any point on this curve, say 3 points, ano? So, let us name that as point B, point C, and point D. So, there will be a corresponding vertical distance of point B to your tangent line at A. And that is named as, ito, TB slash A. Or meaning, pag binasa natin to, deviation of B with respect to tangent at A. Okay? Deviation of B with respect to tangent at A. Similarly, sa C, deviation of C with respect to the tangent at A. Kasi nga, yung reference mo is tangent at A. Ganun din sa D, sabihin natin, deviation at D with respect to the tangent at A. So, yung over A dito, ibig sabihin, tangent at A yun. Yun yung linya ng tangent at A. And the vertical distance between these points are all referred to tangent at A. Okay? So, that's the meaning. So, we now proceed to the area moment theorem. Actually, we have theorem 1 and 2. I will not show you anymore the derivation. So, I will just supplement it by another video with the derivation of this. So, simple lang naman ng theorem, no? Theorem 1 is the change on angles between A and B, ito yung theta AB, is equal to 1 all over EI times the area of the moment diagram between the 2 points. Okay? So, yung nasasakupan ng AB, yun yung kukumputin mo ng area. Anyway, na-practice naman natin on our moment diagram by parts how to compute for the area of the moment diagram. And for the theorem 2, aside from the area, involve lang naman natin yung distance from a certain point. If we are concerned with the deviation of B with respect to A, we'll just all refer the centroids of each of the area from that point B. Similarly, if we are concerned with A, deviation of A, so yung lahat ng area na nasasakupan ng A to B with its corresponding distance, i-measure natin hanggang A. Okay, para siyang, or actually ito, moment of area, no? Kaya nga tinawag na area moment theorem. So, moment of area was discussed on your moment diagram by parts, ano? Okay. Expanding this, ito yung sinasabi ko, na kapag slope lang, of course, meron kang ginawang slope dyan. Okay? Remember, kapag decreasing, that is a depression. And that is normally represented by a negative angle. Ano? So, kapag gumawa ka ng linyang paganyan, Kapag may corresponding angle yan, ano? Itong angle na to usually is negative, no? Ngayon, kapag naging horizontal yan, ibig sabihin, maximum na yung ating deflection. Maximum na yung ating deflection. Kasi ito yung horizontal line, sabi natin, ito yung transition, ano? So, ang susunod dito, nagro-rotate siyang pag ganon, or counterclockwise, from a depression slope, pag sinabing depression, that is negative angle, ano? Negative in our sign convention. Pag nag-move siyang counterclockwise, of course, there will come a time, marireach niya yung horizontal. Itong horizontal line na to, ito yung maximum deformation or deflection. And kapag nag-continue yan na nag-rotate, ito na, angle of elevation na yan, positive angle na yan. Kaya, ibig sabihin, ang orientation ng counterclockwise dito is actually a positive angle. But, remember, kapag may ganyan ka, this is a negative angle, ano? That is a negative angle. And this one is a positive angle. So, as we move counterclockwise, we are actually towards the positive angle. And vice versa. If we are moving clockwise, we are actually towards the negative angle. Okay? So, ito, kapag nag-drawing kang pa ganyan, say this is theta A, and another deviation coming from the elastic curve, eventually, mag-intersect at a certain common point. Okay? So, remember in your geometry, ito yung theta A at ito rin yung theta B. Okay? And yung kabuang angle niya is actually theta AB. Okay? So, theta AB. So, between the 2 points, ito yung point A, point B, kung ano mang area ng moment diagram mo, yun yung consider mo for this slope or the change in angle between A and B. Okay? So, that's it. Now, for Theorem 2, sabi nga natin, we'll just involve distances here. Ganun din ang concept, area of AB, and then kung concerned ka sa deviation sa bandang B, then lahat ng centroid, i-measure mo sa bandang B. Similarly, kung concerned ka sa deviations dito sa bandang dito, A, ito yung deviation, just refer all of the areas na nasasakupan ng A to B, each of the centroid will be measured up to this line. Okay? So, that is Theorem 1 and Theorem 2 all about. So, madali lang to if we have mastered moment diagram by parts. So, yung rules of sign, when we talk of deviation, kapag yung point, ang deviation kasi, ang reference line mo class, is yung tangent line, ano? So, itong tangent line na to, kung yung point mo is above the tangent line, the deviation at any point is positive if the point lies above the tangent line. So, ito yon. Kung ito yung tangent line mo, okay? Ito yung tangent line mo, no? At ito yung point, ibig sabihin, yung point na to is above the tangent line. Therefore, the deviation at B with respect to tangent at A is positive. Otherwise, Kung ito yung tangent line mo at nasa baba yung point of concern mo, that is negative deviation. Okay? So ngayon, ito naman yung sa angle. Kapag depression yan, initially, kapag depression, that is negative angle, ano? Kapag nag-counterclockwise siya, papunta siya sa positive. It is towards positive. Okay? So, kapag ano naman siya, pag ganyan siya, this is positive angle. And if it will move clockwise, ano, magiging 0 siya and then magiging negative. So, this is negative. Ito yung sinasabi niya dito na measured from the left tangent, if theta is counterclockwise, the change of slope is positive. Okay? And negative if theta is clockwise. Okay? So, huwag na nating patagalin. Let us have an example. So, in this example, we involve here a cantilever beam, ABC. It is fixed at point A. Okay? So, meron tayong triangular load. So, ranging 0 siya dito at the tail, yung tail niya is nasa C at yung head niya is nasa point B. So, in here, we calculate the maximum slope of the beam. And then compute for the maximum deflection. So, obviously, ang maximum slope niya, pag drawing natin yun, ito overhang to, normally, ang maximum ay nandun sa dulo. Okay? Kasi ito naman, fix yan. So, habang lumalapit ka sa dulo, andito yung maximum deformation. Okay, sa C. But first things first, we need to compute for the reaction so that we can establish our moment diagram by parts. So, first, we're going to resolve the triangular load. Ito, 1/2, 40 by 3, that is equal to 60. At yung 60, yun na rin yung ating reaction at A. And then, of course, we'll be having a restraining moment at the fixed support. And that could be derived by taking moments at A. So, we have 60 times the distance. Ito, mula dito hanggang dito is actually 5 less 2/3 of 3 minus moment at A. This is equal to 0. And we computed MA is equal to 180 kilonewton meter. So we're gonna place it on the illustration. And the next step is to determine or sketch your elastic curve. Sabi nga natin, walang slope dito, no? So, magsisimula siya sa horizontal line, magka-curve siya pababa niyan. At yung maximum, sabi natin, nasa dulo ng overhang. And then, constructing a tangent at this point, nagsimula nga siya sa horizontal, kaya horizontal din yan. So, 0 yung slope natin dito. Ito, deviation at C, kasi ito point C yan, no? Deviation at C with respect to the tangent at A, ito yung tangent at A, nagkataon na yun yung maximum deformation. Okay? So, deviation at C with respect to the tangent at A is equal to the maximum deformation. Similarly, kapag dito sa dulo, nag-construct tayo ng tangent line, another tangent line, ano? Nandun yung maximum slope. Kasi nga dito 0 yan. Mula dito, pataas na ng pataas hanggang sa dulo, nandito rin yung maximum slope or maximum rotation. Okay. So, we can now construct an equation, theta C, okay, theta C, ano, is equal to theta A plus theta AC. Okay, so ganun lang. Theta C is equal to theta A. So, plus theta AC. So here, theta C is equal to theta A minus theta AC. Paano naging minus yan, class? Tingnan natin ano. Paano naging minus? Yung sign convention natin kanina. Nagsimula tayo sa 0, no? Sa 0. And then, naging depression yan. Depression dito sa maximum. Ibig sabihin, nagro-rotate yan. Nagro-rotate yan clockwise, ano? Nagsimula tayo sa horizontal o naging ganon. Pag dito, naging ganon hanggang sa ma-reach niya yung maximum delta of the beam. Meaning, yung direction natin is in clockwise. In clockwise. So, meaning the change, sabi natin kapag clockwise ang ating direction is negative. Kaya, yung theta AC dito, take note, is in negative. Okay? Now, to simplify this, para hindi kayo malito. Kung titignan natin yung equation, theta C is theta E minus theta AC. So, big sabihin, kapag kinuha natin yon, transpose natin yung theta AC, punta doon. Ang naiwan, theta A, balik mo yung C sa kabila, minus theta C. So, theta AC is equal to theta A minus theta C. So, anyway, so if we intend to put it this way, theta C is equal to theta A plus theta AC. It's alright. Basta, laging tatandaan, kapag pag ganyan, depression yan. Okay? Kaya nga, depression yan, di ba? Yung kinalabasan ng theta C is depression. Although positive yan. Okay? So, kung magpa-practice tayo, kasi from left to right lang naman tayo, laging yung letter dito sa pinaka-left is letter A, di ba? So, kung magpa-practice tayo, kung concerned ka sa theta B, theta B is just equal to theta A plus theta AB. So, ganun lang. So, pag concerned tayo sa theta C is equal to, magsimula ka sa pinaka-left, pinaka-dulo, hanggang makarating ka dun sa point of interest mo. So, parang ito, B. So, theta B is equal to theta A plus theta A to B. So, this time, theta C is equal to, sa dulo, pinaka-left, theta A plus theta AC. Ngayon, pag may D pa dyan, o di theta D is equal to theta A plus theta AD. So, ganun lang. Okay? So, that's the concept here. So, with this, we can establish this equation. Theta C is equal to theta A minus theta AC. So, anong gagawin natin dyan? So, we're gonna work with these equations, no? Kasi nga, yung theta C, yun yung theta maximum, which is the unknown in the problem. Yung naka-bold din dito na deviation at C with respect to A, with respect to the tangent of A, that is the delta max. That is why ito yung mga working equations natin. So, simulan natin dito sa theta. So, before we can establish that point, kasi sabi sa theorem, we need the moment diagram from A to C. Diba? Kasi ito nga, it involves A to C. Okay? Kaya, sakupin natin yung points from A to C. So, pag sinakop natin yan, makukuha yung 60 dito. Of course, do not forget na yung first step dito, nag-establish ako ng point dito. Bakit ito yung pinili ko? Kasi, dinikit ko dito sa triangular load na yan para ma-apply natin yung formula ng triangular load with the area moment diagram by parts. So, wag mong piliin to kasi putol yung triangle mo. Okay? Or do not do it na dito kasi yung tail mo nasa C at yung formula natin is nasa head dapat. Okay? So, in short, kapag may triangle ka, piliin mo na yon yung nandun. Okay? Piliin mo na yung location. So, we select this reference line and then first, dito tayo sa left, ano? So, anong meron sa left? Yung 60. Okay? PL lang yan. 60 times 2 is equal to 120. So, next, yung moment niya naman. Anong moment niya? So, sabi natin, i-lock natin to, i-apply natin yung moment, yun din yung value. Pero ito negative because it will cause a fiber going down for the beam if this is locked on B. Okay. So, tapos na tayo sa left portion. By the way, itong 180, do not extend it here, no? Mata-terminate lang siya doon sa portion. Kasi yung 180, sa portion lang na left yan. So, wag mo nang extend dito. Okay? So, yung load dito naman sa right portion, ito lang, yung triangular load. And that is negative, ano? That is going downwards. So, this is a first degree curve. Magdagdag ka ng dalawa. First, second, third. So, magiging third yan, ano? Third degree curve na yan. With this formula, WL squared all over 6. So, our W is 40. L is 3 divided by 6. So, that is equivalent to negative 60. Okay? So, ngayon, lahat na ng ordinates meron tayo. So, theta C, theta A is 0. Sabi nga natin, walang rotation dito sa theta A. So, set that to be equal to 0. And then, this is the formula. Laging may 1 over EI yan. No? So, 1 over EI. Constant lang naman yan dito. 1 over EI. So, let us just compute for the area from A to C. Kasi ito, theta A to C is just the area nung nasakop ng A to C. Ito yon, lahat ng area dito. Isasum lang natin yan. So, triangle sa taas, positive yan. 1 half 120 by 2. Rectangle sa baba, negative 180 times 2. Spandrel sa baba, negative 1/4 60 times 3. Bakit 1/4? Kasi this is a third degree. Ang general formula natin, di ba, sa spandrel, kapag area, is 1 all over n plus 1 base times height. So, this time, ang n natin is 3. Kaya naging 1/4 base times height. Okay? So, computing, we have theta C will now be equal to negative 285 all over EI. Okay, so let us just correct this one, ano? So let us remain or maintain the arithmetic here because in our calculation, just the same, it will just yield to negative value. Okay? Kasi nag-start tayo sa 0 and we have a clockwise rotation here. No problem dito. Let me correct this that we'll just have to remain or maintain with the arithmetic positive. Anyway, on our calculation, it will just yield to negative value. So, theta C is really negative 285 all over EI. Okay? So, on our deviation at C with respect to A, in-highlight ko dito yung C, ano? Kasi, dito natin kukunin lahat ng distances ng centroid na nitong lahat ng shape na to. Bakit dito? Kasi nga, ito na, moment of area na sinakupan ng A to C because of the deviation with respect to the tangent at A. Okay? Yung sinakop ng AC with the corresponding distances nitong mga shape na to hanggang sa C, ano? Kasi deviation at C. Deviation at C. Kunin mo sa C lahat. Okay. So, we are now computing for the distances. Para madali na tayo, isa-isahin natin. So, triangle, 1/3 ng 2, kasi yon yung centroid dito, plus 3. So, will yield to 3.67. Ito, madali lang to, rectangle. Half ng 2 is 1, di ba? 2/2 plus 3 lang, that is 4 meters. And for this one, spandrel na 3rd degree. So, remember, yung spandrel natin, yung x-bar, kapag ito yung degree, nth degree, so yung formula natin, pag in-apply natin kapag first degree yan, 1/3 of the base, di ba? Pag second degree, 1/4 of the base. Pag third degree, that is 1/5 of the base. So, in this case, we are in the third degree. Itong 1/5 of the base is measured from the head. Diba? Ito yung ulo, ito yung buntot. So, ito yung x-bar niya. Kaya yung naiwan sa kabila is 4/5. That is why this is 4/5 of 3 and that is equal to 2.4. Okay? So, if you have established that, all you have to do is to multiply it by its corresponding area, no? Yan. So, sa triangle, ito yun. Rectangle, nadagdagan siya ng distance from C. At yung spandrel is nadagdagan din ng multiplier ng distance from C. Okay, so we come up with maximum deformation is equal to 1,108. So, ilalagay na natin yung EI dyan, ano, class? So, anyway, you may opt to place your over EI on your solution, especially kapag may change in cross-section, rigidity and elasticity ng bawat properties. So, but if constant naman siya all throughout your beam, huwag mo nang ilagay sa solution, but in the end, just place all over EI. Okay? So, lahat yan all over EI. No? 1,108 all over EI. So, those are the answers to this problem. So, problem number 2. So, this time we have a simply supported beam subjected to 20 kilonewton. Okay. So, we determine the deviation of B with respect to tangent at A. Okay. Gagawa tayo ng tangent at A and then extend natin yung tangent line sa B. So, ano yung deviation? And then we compute for the slope at A. Compute also for the slope at B. And then the distance of the maximum delta from A. So, ito, wala sa gitna yung ating maximum kasi nga hindi symmetrical yung pagkakaload ng 20 kilonewton. So, the maximum deformation is somewhat beyond the center line of this beam. By the way, 6 meter beam yan, no? Pag inad mo. So, wala siya sa 3 meter. Wala yung gitna. Wala yung deformation na maximum sa gitna. So, lalampas siya ng konti. Okay. And then, after which, we are going to compute delta max. Again, first things first, reaction muna tayo. You can do that by taking moments at both ends. Importante na lagi mong check na yung pataas, dapat equal yan sa pababa. So, sa pataas, dalawang reaction, we have 12 and 8 that will yield to 20. At yung 20 na pababa, really, our forces vertical is in equilibrium. Okay, so we place it on the beam, 8 and 12. And then we draw the elastic curve. Gagawa tayo ng tangent at A kasi deviation at B with respect to tangent at A ang hinahanap. At yung tangent at A na yon magkakaroon yan ng corresponding angle. Kasi nga, rotation is allowed at pin connection. Ito yon. Deviation of B with respect to the tangent at A. So to do that, of course, we need to establish the moment diagram by parts muna. So this time, I'm gonna choose this line. Sa segment B tayo, ito ang pinipili kong reference line ko. So meaning, yung 12, wala na yan. So ang ating concern lang is yung 8 tsaka 20. So PL lang naman yan. Starting with 8. So 8 by 6. So 8 times hanggang sa B is 6 meters. So 8 times 6, that is equal to 48. Similarly, yung 20 mula dito hanggang dun sa B, that is 2.4. So 20 times 2.4 is also 48. But that is negative because that is going downwards. So if you notice, wala nga tayong rotation sa roller at B kasi nga we have no additional moment. So, walang excess na moment dyan. So, it will just yield to 0. So, this is our moment diagram by parts. Okay, so we need the distances from B. Kasi nga, deviation at B, ano? Deviation at B. Kaya, lahat ng distance, mame-measure hanggang B. Yung mga centroid na to. So, overall base is 6. Kunin mo lang yung 1/3 ng 6. Ayun na yung centroid. That is 2 meters. For the upper triangle. For the lower triangle, kunin mo rin lang yung 1/3 ng base niya, 2.4. So, that is equal to 0.8. So, we can readily compute for the deviation of B with respect to the tangent at A. So, 1/2 48 by 6. Yung area nito, times dun sa distance niya, 2 meters. And then, minus 1/2 48 times 2.4 by yung distance niya from B, 0.8. So, again, di ko nilagay yung EI dito, nilagay ko siya sa pinaka-answer. So, kumbaga, yung over EI dito, ito na yung pinaka-apelido ng ating answer. Okay. So, deviation at B with respect to A is equal to 241.92 all over EI. So, this is the answer for letter A. Moving on with the next unknown, theta A. Paano naman natin kukunin yung theta A? Well, we'll just have a relationship between the dimensions of the right triangle. Right triangle yan, di ba? Magkaroon tayo ng right triangle dyan. So, anong meron sa right triangle? Meron tayong theta A, deviation of B with respect to A, at meron din tayo yung whole length, di ba? So, right triangle yan. Okay? So, from that, we can just say we are dealing with very small deformation. You know, sa mga beam, maliliit ang deformation, hindi mo mahahalata yan. So, napakaliit versus the length. Ano? That is why in geometry and trigonometry, for very small deformation or very small length, halos equal na yung theta dun sa tangent theta. With that, we can readily write tangent theta. Ano yung tangent theta? Theta A, ano? Theta A, opposite over hypotenuse. Opposite over adjacent. Opposite is deviation of B with respect to tangent at A, and adjacent is the 6 meter. So, ito lang yan. With that, very small nga, palitan natin yung tangent theta ng theta A na. No? So, we come up with that equation. We just substitute what we have acquired a while ago. 241.92, divide mo lang ng 6, yun na yung theta A mo. And that is 40.32 all over EI. Take note, this is negative, ano? Negative yan. Kasi nga, depression siya. Yan. Nagsimula siya sa depression, pababa yan. Ngayon, kapag nag-rotate yan clockwise, counterclockwise, the curve is at peak. 0 yung slope niya. And then, magiging positive siya. Yun yung ina-explain ko kanina pa. Okay? And the rotation is a counterclockwise direction. Okay? And then, for theta B, isusulat lang natin tong equation. That theta B, yung pre-practice natin kanina, no? Theta B is just equal to theta A plus theta A to B. Okay. Nakuha na natin kanina pa yung theta A, that is equal to negative 40.32 all over EI. All we have to do is to, yon, computein mo yung mga area ng moment diagram na nasakop ng A to B. So that is this upper triangle, 1/2 48/6. Ito, minus yan kasi negative triangle yan. Negative 1/2 48/2.4. Then we will come up with this value. 46.08. Tingnan nyo, naging positive na siya kasi yung curve natin dito, pag naggawa tayo ng tangent line sa B, ano na siya, elevated na siya, no? Hindi na siya depression. Okay? And that will be the answer for letter C. Now, for the distance of the maximum deflection from A, hindi natin alam kung nasan yun. Okay? So, I'll just have a point here na yung tangent niya is horizontal. Tangent is at horizontal in maximum deformation. So, ililabel ko yan. Lalagay ko yung reference line ko diyan. At tanggalin na yung right portion. So, we do not know yet the distance of that one. So, we delegate an x for that. Wherein the deflection maximum is located. So, just the same, lagay rin natin yung tangent line at A and its slope. Kasi banda rito yung ating delta max. So, with that, if this is point D, by the way, ito, this is a deviation, ano? A deviation measured from this point, na kapag point D yan, ito, deviation of D with respect to the tangent at A. Okay? So, we label the total of that one by Y. Bakit ko nilabel yan? Kasi, kung titignan natin, right triangle pa rin yan. Okay? Ang angle ng right triangle natin is theta A. Ang opposite ng theta A is Y. Ang adjacent niya is X. Ngayon, kapag sinulat mo yung tangent theta A, that is Y all over X. Palitan natin ng theta A. Tanggalin natin yung tangent kasi nga, we are dealing with very small values. In short, theta A is approximately equal to tangent of theta A. So with that, By cross multiplication, y is equal to x theta a. So, punta siya dito, x theta a na. Okay? So, we established our diagram by parts on that. Ang involved lang naman dyan is yung concentrated load na 8. So, 8 by x, that is 8x. And this is the distance. We do not know. And we note that theta d is equal to 0, no? Kasi yung d kasi, yun na yung pinaka-peak wherein the curve is at horizontal slope. Okay? So, theta d therefore is 0 slope. And then, sulat ulit natin. Theta d is equal to pinaka-left, theta a, plus theta a to d. So, nakuha na naman natin yung value ng theta a, which is negative 40.32 yun. And then, yun, include mo yung a to d. Ito na yung ating moment diagram. So, that is simply equal to 1/2 base times height. 8x times x, or that is 8x squared. So, by manipulation, transpose mo lang yung sa kabila. And then, by arithmetic, we have x is equal to 3.175 meters from A. So, this should be the answer for letter D. Okay? Now, for delta max, we will just have to use this relationship. Ano? Ano ba yung relationship na yan? Kasi ito, y yan kanina. May express natin yung y in terms of x times theta A. And actually, ito yung sum pala ng x theta A or yung sum ng delta max at deviation at d with respect to the tangent of A is actually this one, x theta A. So, yun. Pinag-equate ko na yung sum nito dun sa y, which is x theta A. So, nandito kasi yung delta max na hinahanap natin. Ano? So, but before that, alam naman natin yung x. Ano? Alam naman natin yung theta A. Ang hindi natin alam dito, yung deviation of d with respect to the tangent at A. So, we compute that one using this diagram again. Ngayon, kailangan natin yung distance ng centroid nito hanggang dun sa D. Okay, that is simply 1/3 of x. Ano? Triangle lang naman tayo, no? 1/3 of x. So, yung area mo kanina, 1/2 8x squared. Dagdagan mo lang ng distance from D of the centroid, 1/3 of x. Okay, so by manipulation, kasi sa-substitute na natin dito yung value ng x, okay, which is 3.175, then we can arrive with deviation at D with respect to the tangent at A equivalent to 42.67 all over EI. So, yun nang gagamitin natin. Substitute mo ng x, absolute value yung 40.32 class kasi wala namang negative distance, ano? Dito. Okay? So, absolute value yung 40.32 is equal to delta max plus 42.67. So, by manipulation again, balik natin yung all over EI doon. So, we come up with delta max is equal to 85.35 all over EI. So, I think this ends our lecture for today. So, it would be nice if you're going to have more practice on the principle. Anyway, pare-parehas lang naman yung process. Just stick to the concept and perfect or master your skills in establishing the moment diagram by parts as well as computation of area and distances of the centroid. So with this, you may now have your practice and have a good day.